So, yeah, thank you very much for having me here. I really enjoyed the conference so far. I hope you as well. My name is Ivo Blohm. I'm assistant professor for management and for data science and management at the University of St. Gallen. And in the last 1.5 to 2 years, I was very keen about finding out what makes the data-driven organization, what's it all about, how organizations must transform. And today I want to share my insights for you. First, what does that mean on an organizational level? How do organizations have to adapt? And then maybe one level deeper for you as a manager or marketeer, what might your chances be in that evolving business area? Well, there are manifold use cases that show how great and how bold and how good AI is, and I don't want to dig into details here, but I very much like this example. This is Aux Money. This is a peer-to-peer lending platform from Germany, and this shows very nicely what AI can bring us for many, many use cases. And at the end, it always boils down to the four, different dimensions of being faster, being better, being more innovative, and being cheaper. Well, this platform works like that. If you have a credit request, you can make a proposal to that organization, and then if you get access to that platform, other people and institutional investors can invest into your grant or in your credit, and then you pay back that loan to all the small investors. And under the surface, this company is some kind of big data company, because if you make an application there, you put into some kind of different models and you get a risk scoring. So if you apply at night, you get a worse credit scoring, because if you have had a real job, you wouldn't apply for a credit on that page. Well, data is bought from rating agencies like InfoScore. Well, it's checked how many typos do you have in your application and many, many other things. And after that, you get a credit score. And this works more or less in real time. And the company had to delay the decision to customers because the customers didn't accept, well, they have scored me in 3 seconds. How can that be? So it was just not accepted. The second one is that with big data approach, then can go into a market segment that was unserved. This platform only serves customers in the subprime segment that don't get credit at banks because the risk is so high. And with their big data approach, they can identify the customers that have just enough money to pay back their credit and nothing else. But this is quite effective. Third, the entire process is completely automated. There's new human intelligence involved. And it was when the offering started, it was a quite innovative approach, because it was the first offering on the market in Central Europe, was completely automated online credit process. These 4 dimensions can be applied to almost any AI project, and so this is, from my point of view, the common sense. If you go to the domain, and people that are good in these 4 dimensions, there have been various studies that advanced business analytics leaders, so the companies that are quite good in applying analytics in their daily operations, are more productive, more customer-oriented, more successful. My colleagues from the MIT say it's about 6 to 8%. If you go to a consulting agency, they say it's about 80 to 120%. If you go to the IBM and Microsoft Azure, they say about 400%. So the scale is varying a bit, but the bottom line is pretty much sure. So if you're good in these domains, your business will be more successful and more productive. And based on that, considerations, I started to dig deeper. What is it? What makes an advanced business analytics leader successful? If you go to a marketing domain, there are some many use cases. I don't want to dig into details here. Some of them have already been presented. There will be more in the afternoon. But this, some from our partner network, where about chatbots like PostFinance is using. Swarovski is using recommendation systems in the business-to-business domain. This is a pretty interesting project, because most things we have talked today were about in the business-to-consumer business. And if you apply all these concepts to the business-to-business domain, you're kind of data disadvantaged. And it's really hard to build robust models here, because you don't have enough data for neural networks and all that fancy stuff that has driven all the AI hype. And if you go to media agencies, all of them have very, very sophisticated marketing attribution models that show how much is the ROI for each TV spot and all other marketing things we're doing. the interesting thing is that all these companies drive AI and big data for, well, making some what they call digital transformation. And again, here are 3 different dimensions. You can do it in a completely backstage perspective, like Aux Money. You don't see it. That's a big data company. They just have automated and augmented their business processes with that. On the other hand, if you look at chatbots, for example, you're, well, innovating at the customer interaction. So, well, you have other means for serving digital customers. And finally, you could also integrate that into your products, so that you have smart products, or however you want to call that. It doesn't mean that you have to, well, excel in all 3 dimensions, but these are just dimensions or roads you can take to drive your business. And what I have recognized in the last years, it was some kind of driving motivation into that field, that many organizations, mostly all of yours, start pilot projects for getting that stuff on the road, and most of them will fail. Sometimes because our ROI expectations are so high that they can't be fulfilled. Sometimes it's a mere technology focus. Well, we need Hadoop or Spark or whatever. And then when people don't think about what we can do with that new technologies, it's not clear what happens with a prototype or new project when it goes off the lab. So there's no responsibilities defined, no roles, etc., pp, and the things die. Other ones are, well, many of your organizations might have marketing analytics teams or something like that. As far as I have seen them, they try to be as separate from the IT as possible, but at a certain point of time, if you want to build large-scale solutions in production, there is no way around IT, because these guys usually own the data, they have the databases, and so on. And there's also some loss if you want to transpose the projects. And sometimes, well, the projects are rather driven by IT or, well, other departments, and the potential stakeholders that should use them are not focusing on that or have no commitment to use that. And so, well, getting big data and AI on track is some kind of, well, stages. You have some, well, initial focus on exploring new possibilities, building prototypes, evaluating use cases. Then you have make them technically reliable. They have to be in production. This is hard work. This is usually done by the IT departments. And then you have the biggest block. You have to change your organization. If you have some kind of algorithm or prediction machine or something like that, it doesn't serve anything. You have to integrate that into your business processes. There's one, well, buzzword like business process redesign. It's really 90s, but this is what is coming in the next 10 ages to us, because everything has to change if you take that chance seriously. And, well, an interesting study I found a couple of months ago was done by McKinsey. They asked, well, 10,000 organizations, so how do you invest your budgets into analytics and so? And the interesting thing is that the business and analytics leaders, that the top 8%, so all the online retailers, Amazon and like that, invest about 25% of their entire budget for IT and related stuff into analytics, and the average organization only 5%. And the other thing that is quite interesting is that they invest most of the money in the organizational integration phase, in changing all the decision-making processes, business processes, and so on. And the average here is only 23%. So there's some kind of really diverging pattern of how the organizations that are good at that approach analytics. It's not thinking about, well, pilots and use cases. It's about, hey, let's transform our business, and then it can really pay off. And, well, before we can deeper, I think we have to speak a bit about a bit of definitions. Okay, I'm an academic, and this citation is a bit outdated, but you can replace big data by AI, but it's so true. Big data is like teenage sex. Everyone talks about it. Nobody really knows how to do it. Everyone thinks everyone else is doing it, so everyone claims they are doing it. And this is pretty much the situation as it's found in every organization. So if you go out and ask, hey, are you doing big data? Hey, yeah, of course we do. But if you, what are you exactly doing? Yeah, I don't know. I have to ask. And then, well, we have one product in which we ask this Microsoft Azure API for face recognition or whatever. So it's not really what we would consider as AI or something like that. And, well, further, well, to further illustrate where I want to go with you, we need to speak about some things. Well, what most companies of you do is business intelligence, that's creating reports, data warehouses, and so on. The interesting thing about that, from all of these concepts here, is that's the only thing that contains business in it. All others are some kind of generic, well, technologies that could be applied in medicine, biotechnology, autonomous driving, but they have no direct impact on the business. And this is why I'm here, because I think there's a huge gap. For example, if you look at big data, from my perspective, it's rather a technology-driven thing about how to build big databases that can save unstructured data in large amounts, but it has no business implication at the end. The same with machine learning. This is a set of algorithms that can detect patterns in data, and when you have good patterns detected, you can infer from that to other cases, to other customers, and make some kind of predictions. Data science is a bit more well applied. From my perspective, it's applying machine learning to problem solving, to making predictions or whatever. So it had some kind of practical value. And artificial intelligence was the attempt to build machines that might take intellectual tasks with a comparable performance as humans do. There are many approaches to do that, but machine learning so far is the only thing that really worked so far. But what doesn't mean that there are other approaches, but so far this is the state of the art here. So, and if you want to apply that in your organization, it's worth to make one step back and applying AI to cooking. So you need some ingredients. This is cheese, tomato, whatever you need. When you need some kind of appliance where to cook the pizza, then you have a recipe that tells you how to combine the different ingredients. And when you have a dish like a pizza, as well, the pizza doesn't serve anything. If you're hungry and sitting in front of the pizza, you're very dissatisfied. So you have to eat the pizza in order to get all the value that can it bring to you. And the same, it's for big data and AI. You have data, you have algorithms that are ready-made appliances, you have models that something that you have to develop in your organization. So how can I apply this algorithm in my business context? Then you have some outcome, and then you have bring that into daily usage, and then you can make the difference. And let's make a small thought experiment. Imagine you would employ a baker to construct an oven and an engineer to bake a bread. Everyone knows you well. I don't think that this will be a successful talent strategy or whatever, but this is what almost all companies are doing when it goes to big data and AI. They go to organizations like ETH or other well-known universities, hire machine learning engineers. These people are really, really good at constructing new appliances and developing new algorithms, but they're not so good in bringing that into action, into bringing that into daily life of the operations. And the second thing I recognized after a couple of time thinking about that successful business analytics leaders are some kind of industrial bakeries. They have industrialized, large-scale, that process of turning data into usage, and this is what makes the difference. And the thing is a bit arduous. So we academics love to put things in frameworks and to organize them, and this is one that we use predominantly for that. This is some kind of what we call the St. Gallen house of digital business. It starts with putting the customer on front, being customer-centric, developing some kind of strategy, how to serve our customers, building structures and processes for doing that, enabling that with technologies, and then you have some surrounding tasks like management, product management, and in this case, also data and some kind of exploration and production processes. And if you want to build a data-driven organization, you have to develop some kind of data strategy. So where do we want to go? This has to be in line with the overarching corporate strategy, maybe also with your IT strategy. You have to build organizational processes that can work with the data, so that can apply that. You have to scout technologies that are using for that. You have to develop change management processes. You have people explain what the model is doing, what the outcomes are. Most people just don't understand that. And if you just don't understand something, your natural reaction is not, oh, I want to use that. This is so cool. Rather, I don't think that I will use that. It's not good. Then you have to be customer-centric in some way. You have to find a way how to, well, translate your customer needs into statistical models. So if your customer is dissatisfied, your statistical model won't help that much. You have to identify appropriate actions with the model, for example, that then can be applied to customers. Well, you have to also think about data defense, data governance, compliance, GDPR, and all that stuff. Without that, you will be sued quite quickly, I guess. And then you have to develop that processes for being agile at the beginning and then scaling that up technically. So that there are completely different domains carried out by different business units, so it's quite complex to bring that into work. And the other thing is that the business analytics do is they have created a new role. Analytics translators, they are called, and these are quite make or break. Because, well, if you have some kind of business problems that go to the domain of marketing, so your prevailing problems are like, well, we want to improve our customer experience, we want more sales, we want more leads. Well, if you speak to a data scientist, his questions are rather, is this an unsupervised or supervised machine learning problem? Is this classification or regression? How is data quality? And there is some gap between the two worlds. And these people, well, their profession is to bridge that gap. And the good thing is that these people are usually no data scientists, data engineers, or analysts. They're rather people that come from the forefront of marketing, from the operational business, and then have been trained or got somehow in the domain and applied some technical knowledge so that they can translate the problems of marketing or whatever domain they're working in to data scientists that they then can build a model. And there have been so much buzz around why the data scientist role is special. At the end, we're just statisticians, computer scientists, and I'm coming from Technical University of Munich, and there was some joke. How do you can identify an introverted or an extroverted computer scientist? Well, the extroverted computer scientist is looking at your shoes when he's speaking to you and not on his own shoes. And this is pretty much also true for data scientists. And it's just not their job, in my opinion, to figure out what are the problems with the customers, with the business processes, or what other requirements the business have. So this is the perfect role for some kind of analytics translators, and this is the great opportunity for you. I think every one of you who's willing to train himself or herself can do this role, because there's not that much analytical knowledge required. It's rather about speaking the language of data scientists and bringing your problems in a language and a problem formulation that they can understand. So we have done some research about what analytics translators have to know and what are the domains they have to be good in. And the first one is something that we call compete on analytics. So we have to understand how the business works, how to translate their products, their services, their business into the data-driven world that has some new rules that have to be implemented and learned. We have to think about how can we constantly develop data-driven organizations. This is not that easy as it sounds, because most big data in AI projects I have seen so far are something like the new Ultra 4000K television that no one really needs. And the second one is that these people have to develop some understandings about managing data as a strategic resource. We have to get an overview, okay, for this kind of problems, our organization has this data. Maybe we have to buy or collect some other kind of data. We have to aggregate that. We need some technical proficiency for that. I spent so many time speaking to some top managers explaining why data engineering, cleaning data is about 80% of the work, and they just don't understand this because they don't feel the pressure about, well, this data comes in this format and this and that, and it just don't complete, or it does not match. And this is one of the basic things these people must understand and be able to translate in a way that even decision makers can understand. That this is the duty of most projects. Then, of course, they have to be able to speak big data and AI. They have to be familiar with the terminology. They won't build models on their own, but they have to have some basic understanding. Okay, this is some kind of this problem. This is a good model. The other model has been evaluated in an appropriate way, so it's no buzz that the data scientists explain. And finally, they we have to be the people that build the data-driven organization and change that, and scale up all the data science operations. So based on these insights, we created some kind of, well, CRS. It's big data and artificial for managers. If you have any questions on that and maybe are interested in becoming an analytics translator, please reach out to me. It's starting in November. It's a pretty cool program. We have about 12 different lecturers coming from computer science, law, business, so that you can get the entire perspective on the field and lead the data-driven transformation in your organization. Well, yeah, thank you very much. I was a bit over time. I hope not that much.